All right, this is our last topic, titrations. In titrations, we put together most everything we've done as far as calculations with molarity and so on. We're going to put that together. The only thing we're not going to be doing is calculating pHs in this particular type of problem. Now, this is a complicated problem because it's going to ask us to predict what the products are, make sure our equation is balanced, pull out the information from the question, determine the moles from the known, convert moles of known to moles of unknown, and then finally use our information to calculate the concentration of the unknown. So to start the problem, I'm going to read this. It says a 225.0 milliliter solution of hydroiodic acid is neutralized by 37.5 milliliters of a 0.188 molarity potassium hydroxide solution. What's the concentration of the hydroiodic acid? First thing I need to do is to create an equation here. So I've got my HI plus KOH. Those are my reactants. Now remember that a neutralization reaction is a double replacement reaction. So this is going to combine with that, and that's going to give me HOH. And remember, that would give us a formula of H2O. So there's my water. Now what's left over is going to be the iodine and the potassium. We're going to write the potassium first because it's got a positive charge, and then the iodine. The next step I have to do is to make sure that my charges balance. I look on the periodic table. This has a +1 charge. This has a -1 charge. So when I crisscross my charges, it's going to be 1 to 1. So that's just what I need. I'm going to take my pen. Whoop, don't want to do that. My eraser's too big. Let's erase. I'm just going to erase some of this so it's not quite so messy. All right. Now, the next thing that I need to do is to make sure that it's balanced. So on one side here, I've got hydrogen. I've got 2 hydrogen on my reactant side. I've got 2 hydrogen on my product side. I've got 1 potassium. I'm going to just get rid of that so it's a little bit less stuff to write. 1 potassium on the product reactant side, 1 on the product side. It looks like this is balanced as it is. So my coefficients are going to be 1, 1, 1, and 1. I'm going to need that for my mole bridge. Now the next thing I'm going to do is I'm going to pull out the information from my question that goes with each thing. So my volume for the HI is 25 milliliters. I know that I'm going to need all my volumes in liters, so I'm going to go ahead and convert that now. If I divide 25 milliliters by 1,000, it's going to give me liters. So 0.250 liters. Now I'm going to read across here. I've got 37 milliliters of a 0.188 molarity potassium hydroxide. So those numbers are going to go with this. Again, I'm going to convert it to liters. 0.375 liters. And my strength is 0.088 molarity. And it says, what is the concentration of the HI? Well, that's got to be my molarity. So I got to solve for molarity. So step 1 is going to be to take my known and find the moles. So molarity, the formula for molarity is moles. Molarity is equal to moles divided by liters. So I've got the molarity here is equal to moles, which is what I'm going to solve for, divided by liters, which was the liters was 0.375 liters. Remember, I can cross multiply that. I'm just going to put a 1 under it. Cross multiply, and pause the video here so I can put this in my calculator and I'll get you the answer. So what you're going to get is a molarity equal to, or sorry, the number of moles is 0.00705 moles. And that's going to be of my known, which was KOH. Step 2 is going to be to take my moles of KOH and convert it to my unknown, which is moles of sodium moles of HI. So I know I've got this many moles of KOH. So now I'm going to use my mole bridge. So this box here is going to be my mole bridge. So I've got 1 mole of KOH to 1 mole of HI. Put that in the calculator, and I don't really even need to put it in the calculator because it's basically multiplying my answer by itself, so it's going to give me the same number. But this time it's going to be moles of HI. The third step is to take my moles and the number of liters and calculate that molarity. So molarity is moles divided by liters. So my moles is 0.00705 divided by my liters, and my liters I was given in the problem. So let me get that into blue, 0.0250 liters. I'm going to take that, and so my answer divided by 0.0250 is going to give me an answer of 0.282 molarity. Oops, and I just wrote over my decimal point. There you go. Now, the last thing I'm going to do before I turn you loose on this is I'm going to walk through how you do the formula for this next one, because there's a little bit of a trick to it. So you can read the question for yourself. I'm going to pull out the reactants. I've got copper hydroxide, and this is going to be H2C2O4. Find the polyatomic ion. That's going to be oxalate. So this is going to be oxalic acid. But right now, all I'm doing is writing down the formulas, so I don't really even need to worry about the names. Plus my oxalic acid. I'm going to do my double replacement. This is going to combine with this to make water. This is going to combine with this to make my salt. I got to make sure that my charges have been crisscrossed. So I'm going to look up that oxalic acid. And when I see oxalic acid, or the oxalate is what it would be, it has a -2 charge. Now, if you look at copper, it's going to be in that zone where it's a transition metal, so there's no charge written above it. So I have to do a little bit of deductive reasoning to figure out what the charge was. I'm going to come back over to the other side here, and I see that it's paired with the hydroxide. Hydroxide has a -1 charge. If I only needed one of those coppers to go with that hydroxide, that must mean that the copper has a +1 charge. So I can say that the copper has a +1 charge. I'm going to crisscross my charge numbers, and it's going to give me Cu2. Then my polyatomic ion, I only need one of those, so I don't have to write anything down. So that's how you're going to do your formula. Now you're still going to need to balance your formula, so you need to go ahead and balance this formula. So balance this chemical reaction, get your coefficients, and then you can continue with the problem. So your answer for question 2 and 3 are going to be, so here's your answers for questions 2 and 3. For question 2, the answer is going to be 0.74. For question 3, it's going to be 0.038 molarity. All right, if you have questions, let me know.